Hello everyone, this is Hadi. So in this tutorial we're gonna implement gradient boosting tree classification in SparkML, and then we're gonna do cross-validation parameter tuning on top of that. So uh, First we're gonna do the implementation, all the steps required for GBT classifier. And then we're gonna do evaluations of our model. And at the end, I'm gonna tell you how to do cross-validation tuning and find the best parameters for your application. Um, a quick overview of boosting versus random forest. In our case, it's gradient boosting trees. So in like to compare them in a high level, boosting is based on weak learners. Normally, in our case, where weak learners are decision trees are pretty small decision trees, not that much depth or not that many branches, and those learners are put together back to back, and we first train a weak learner, and then based on the results of that high bias and low variance learner, we will add another weak learner after that, and then again based on the results of these two, we add another one, and we keep going until some um, conditions are met. But in random forest, we use multiple decision trees, but these decision trees are normally fully grown, multiple branches, like uh, higher depth, and it's but the thing is, you don't have to train these trees like back to back. You have to like serially. You can train them in parallel, so they're kind of independent of each other. So this is the difference. So and this in fact um, makes sense. I mean, because of this fact, it makes sense the namings that are used in these two models. I'll get to that. One thing is that boosting has multiple variations, light, gradient boosting, or the other variations, XG boost. So they're trying to make it faster or sometimes better in terms of results. But still, the fact that these trainings have to be serially, it can't skip it completely. Sometimes they might do some parallel computations, but it's something that they're just trying to do some techniques to make some parallelization at some parts, not all parts. Um, so let's start with the implementation. So again, I'm skipping many parts or going fast at some parts because we have already covered that in the first two tutorials. And especially the other tutorial, second tutorial, which was on random forest. So we read the data in here. We are using the option of infer schema. So we are asking Spark to infer the schema of the data when it's reading it. So let's see how it performs. So now if we look at the schema, you'll see that, so again, just to remind you what the data was, we have manually crafted data of multiple columns: ID, income, state, gender, owns car. So at ID 1, this person has 40,000 income, lives in California, it's a male, and he doesn't have a car. So we have created these. It's just a pretty small example for our tutorial. Um, Going back to the notebook, Zeppelin notebook. So you see that here, once we read the data, it has correctly found the schema. This is pretty useful if your data is well structured. So state and gender are in string format. Owns car is Boolean, and income is double. So our goal is to use income, state, and gender as features and predict owns car. This is the goal in this example, similar to other tutorials we had so far. So skipping some details because you have already covered them. So we just do string indexing. But before that, since owns car is defined as a boolean, and this might cause issues for the string indexer because it only takes integer or string, we're gonna define data df, which is just casting owns car as a string to a string type in here, and then we just go ahead and define a string indexer for that, and you can see the results. You already see them here as you have seen it before. For categorical features, state and gender, similar to random forest, you don't need to do one-hot encoding, you just need to do string indexing. So both gender and state, we define a string indexer for them. You can also see the results on the data. And then we put all the columns that we're going to use in our model into a vector using vector assembler. Again, similar to random forest. So for continuous features, we don't need to do normalization. Again, I repeat it. This is similar to random forest. You don't need to do that. Even some people suggest not to do it to make sure you don't lose information. Sometimes based on the normalization that you use, you might lose some information. Now we get to define the classifier. So we define the GBT classifier. You need to set the label column, which is owns car index, features column, features, and similar to random forest, you can set other parameters, or you just use the default values. But let's say max iteration, the default is 20. I'm gonna set it to 4. So this is the number of trees. So that's where I mentioned at the beginning. So in random forest, remember in random forest tutorial, we had set number of trees, but in here it's set max iteration. But both are referring to number of trees. So that's like the way they are built is the reason that they have different namings to make sure it's not confused. So the trees here are like weak learners, and they have to be sequential in general, but in there the trees here are fully grown trees, and then they can be trained in parallel. So the next parameter we are setting is the max depth, which is similar to random forest. The default is 5, we set it to 3. Once we define that, please note that as of now, which is Spark version 2.2.0, GBT classifier in SparkML doesn't support multi-class labels. It's just working for a binary classification. Only 2 classes are allowed. But in near future, the plan is to bring the multi-class labels support. So let's see what other parameters are there. So there are some parameters that are common between GBT and random forest. You can check the definition of those using the link provided here. I mentioned like how to do that in tutorial 2. You just click on this and search for the name of this, let's say max bins. Then you will find the definition in the comments. There are other parameters that are coming from, so tree ensemble params. Again, this is common kind of with the random forest. Only these set of parameters are specific to GBT. And I have already told you what they are. Like max iteration is the number of trees for weak learners in general. Step size is the learning rate, and the loss type only supports logistic loss type for now, but I guess in future they might have other functions, other loss type added to this. Once you define your GBT classifier, you can put it into your pipeline. This is repeated multiple times, so it's the only difference is that instead of random forest, I'm putting GBT. and then we do a train test split. Let's do the fitting. Now we fit the pipeline on the train portion and we get the model, and now we can do predictions on the test portion. Since it's so, one difference here is that in random forest we had, after we do this, we will get raw prediction, probability, and prediction. When you do predictions, when you do transform, you get these 3 columns added. But in this GBT, you only get prediction column added. And maybe in future they might add some other columns, but for now it's just prediction. So you can look at the car index, owns car index, and prediction and see how it performs. You see this one, the actual one is 0, the prediction is 0, so this is correct. The actual one is 0, the prediction is 1, this is wrong. This is 0, this is 1, this is wrong. So we're not expecting that our model performs well, because this is a very small set of data, and in general this is just for the sake of this tutorial. So 1 out of 3 is correct, so it's not bad. And also, similar to other tutorials, you can find out what are the labels indexes using this command. Let's do evaluation. For evaluation, you can since we are having 2 classes only, so you can use the binary classifiers evaluator techniques that I mentioned in tutorial 1 to find AUC, ROC, or other metrics that are for binary classifications, or for multi-class classifications metrics such as F1 score or rated precision or recall or accuracy. You can use the one that is mentioned here. This is similar to tutorial 2.1. Actually, I should mention the second tutorial on the random forest. In here I'm using I'm looking at F1 score, and I'm measuring it on the test predictions and see what they are. So it's 0.4, our F1 score. But remember, although I'm saying multi-class classification evaluator, we only have 2 classes in GBT right now. But in general, this multi-class classification supports binary classification, because by definition, it's binary classification is a special case of multi-class classification. So now let's see how to tune. So remember here I had 2 parameters set here, max iteration and max step 4 and 3. Why 4? Why 3? Why didn't I put, let's say, 2 here instead of 4? So this is in general a good question to answer. So and I'm gonna answer it here. So as before, we're gonna put everything back to back in a function, and I'm calling this function train GBT model, and put everything that I mentioned, I have already mentioned in here to create a function, and you can put this into another file, a Scala file, and just run it and all that. It makes it easier to follow in a code base in general. Everything is the same. Again, remember, similar to random forest, the indexer only returns string indexer for categorical features. There's no one-hot encoding as the one that we had in logistic regression. One other thing, so you see feature assembler, GBT classifier, but there is a difference here. So in GBT classifier, I am removing these 2 parameters that I set previously. So set max iter, I'm removing it because I'm going to add it in the cross-validation, and also set max depth. So evaluator is as before. I define the evaluator. I use the F1 metric. So here is where we are doing the cross-validation. So I'll quickly remind you of the cross-validation, how it works, but let me tell you how to implement it first. So you need a param grid builder. So to use that, you need to add it here. So it's a part of SparkML tuning. You add param grid builder. Also, you need to add cross-validator and cross-validator model. So once you do that, you can define a param grid builder and add grids to it. So One grid is max iteration, so it's gbt.max iteration, and I'm saying I want to have 3 points, 3, 4, and 10. So, and then the other one, again, instead of set max depth that I had here, I just add another grid and say gbt.max depth. I want to have it 2 values, 2 and 3. So I built this grid. So now this grid has 3 points on this aspect of it and 2 points on this side. So it's like 3 times 2, 6 grid points you have. And then we do a grid search. A cross-validation is going to do a grid search and find the best parameter set. It will say at the end, hey, 4 and 2, 4 for max iteration, 2 for max depth is the best. We will see. I don't know. I'm just guessing. But so let's see how to do the rest. So the pipeline is as before. You add all the stages, label indexer, and GBT at the end, and you define the cross-validator. So cross-validator, you need to set the estimator, which is the pipeline, the one we want to train on. So the evaluator is the evaluator we defined as before. We need to pass the parameter grid that I have just built here. I pass it, and then the number of folds. So I passed 3, which is good enough, I would say, in general. So now once you created this cross-validator, I call it CV, and then I run cv.fit. So it's by itself an estimator, and you need to fit it on data to get a transformer. Once it's fit, it's a transformer. It's a trained model. And one thing I'm doing here, I am serializing this on the disk. So I'm writing that to a disk, to a path that I know, and later I can load back this to Spark and do some other analysis. And this is a good practice in general. So let's discuss briefly what this cross-validator is doing. So in general, remember we said like there is 3 points here, 2 points here, 3 times 2, 6 grid points. So what it will do is that this will take the data and divide it into 3 folds or 3 parts. And then for each of those 6 grid points, it will fix one grid point and use those parameters on that grid point. And it will fix one of the parts of the data and take that as a test set. And then the other 2 are used to train the data on. And again, that grid point parameters are used in the model. And it will fit on the other 2 folds, and it will get a model. And then it will measure the F1 score on the test portion that was fixed. Then once this is done, it will change the test portion. It will fix another part of the data and take the other 2 as a training set, and then train the model on those 2 training sets, and then it will measure the F1 score on that second test part. So, and it will do this one more time for the other part, the other remaining part. So this way, it will just changing the test portion, and consequently, the train portion is going to change. It will do this for each of those 3 parts, and the 3 F1 scores are measured, and then it will take the average of that. And that average will be assigned to that grid point parameters. Then it will do the same for all other grid points. So we have in general 6 grid points. So we will have 6 average F1 score. And it will take the best F1 score for each of those 6, between those 6 grid points. And it will return you that best parameters and the model corresponding to that. So let me run this. You can, I mean, if you're not remembering details, or you want to know more about cross-validation, you can Google it. It's pretty straightforward how it works. So we run this. Now I'm gonna use that function we defined above and train a model. And then once the trained model is obtained, I will make predictions that transform. I make prediction on all the data. So data df is all the data that we have, remember, from what we have. So you see here, our model, our GBT model, is taking a while to run compared to other tutorials. In there, it was like 1 or 2 seconds, but it's now multiple seconds here. The reason is that we are actually, so there are 6 grid points here, and then there are 3 folds. So for each, like each fold that we keep as a test part, and then the other 2 for training, we are training 1 model. So it's in fact 6 times 3 models are trained, which is 18 models are trained. So that's why it's taking a while to run this. So should finish soon. So as you see, this is quite taking resources. Our example is pretty small, but in like larger examples, real life examples, it might take an hour, 2 hours, depending on your resources and how many CPUs you have or how many machines you're using. So this is now done. I'm taking the columns, looking at the columns and the first row. The columns are as expected. We have prediction column, and then you see own scar and prediction are the last 2 columns. This is own scar, this is the prediction, which is a correct prediction. Let's move to the part that we are finding the best parameters that are chosen by cross-validation. So remember I saved our model on disk. So I can now read it back. So I'm doing this, I'm loading that model. I call it a CV model. Then I'm gonna look at the best parameters. What was the best parameter for max iteration or max depth? We'll see. So what I'm doing, this looks like a magic, but it's not actually. It's pretty simple. So I'm saying cross-validation model, the CV model, it is a cross-validator model. I already know that. So I cast it as a cross-validator model. And then I take the best model. And then I know that our model was a pipeline model. So I'm casting it as a pipeline model. Then I call this best pipeline model, BPM. Then I'll take the pipeline model. You know, the last part of the pipeline that we had is GBT. So to take that one, I said take the stages and give me, so this is the index of the last stage. So give me the last stage, and I know that's a GBT classification model. So I cast it as a GBT classification model. I call this GBT model. Now I can look at the parameters of this model. So GBT model, I can get the max iteration, which is 3, and max depth, which is 2. This is kind of surprising. Because of our example, these smaller values work best. So what we passed was 3, 4, 10, 3 works best, and 2, 3, 2 works best. So in general, in practice, since it's expensive to run cross-validation tuning, normally people run it for multiple customers or multiple applications of the same nature, and that once they find or narrow down the parameters for each of those parameters, the values for each of those parameters, then they can just fix them and then remove the cross-validation. Or once you do that, then you just set them here and then remove the cross-validation. Or you can at least make the grids much smaller to use less resources. And that's the way you find your best parameters for your application. Thank you very much. As always, feedback and comments are appreciated, and please subscribe if you like the videos. Thanks.